Welcome back. In this video, I'm going to look at visualizing Lidar data in Python. So I just learned how to do this myself. I'm not fully versed in what all is going on in the back end yet. I mean, most of it's pretty self-explanatory, but I didn't write these packages. I don't use them every day. I've just been uh, I've had some documentaries on in the background and some shows from History Channel, and they've been using a lot of lidar data to image some things. So I thought, well, I wonder if I can do this in Python and how hard it would be. And it's surprisingly easy to do. So what I'm going to do is I am going to show you where to get the where you can get some lidar data from. I'm going to show you where I learned these quick simple steps to do this. I found it in a Medium article, um, and I also found the data source from a reference from that same Medium article to another one by the same author. So if you're interested in this kind of stuff, I suggest you follow that author on Medium. So again, all I'm doing is I'm taking what this author said on Medium, like this is how you do it, and I'm just showing you how you can do it in Python. Okay. So and I'm also going to show you where you can get some LiDAR data from. And so with that, the first thing we're going to do is we are going to go get the LiDAR data, because pulling the LiDAR data can take any amount of time depending upon how much data you pull. So I pulled the maximum, and it took a while, maybe 30 minutes. And then I pulled, a smaller amount, and it took maybe a couple minutes. So we're going to do that first so we can get that rolling in, so we can get it processing. And then once that's complete, I'm going to move it into the file directory, and then we can see it and work with it inside of Python. Okay, so the first thing we're going to do is we are going to, and also I'm going to provide links to everything. So I'm going to have links to where you get this data from, what is LiDAR point cloud data. This is one of the articles I was talking about, and how to work with it. And we're simply going to take this code right here, and we're going to run this code. And I'm just going to show you how easy it is, okay? And then it uses Open3D. So I'm going to provide the PyPy URL as well as the docs for it. And then also it uses LASPy. I'm going to provide that PyPy and docs. And then of course NumPy. And it only uses one NumPy function, I believe. So I'm just going to provide the direct link to that NumPy function. So apart from that, another thing I'll do is once I'm done, I will push this to GitHub so you can pull it down. And then that way you can just clone it and use it for yourself for whatever you want to use it for. So with that, let's go ahead and get started. So you have to create an account, and you can create a free account. And then once you do that, you go into, let's see. So you can see that I ran 2 jobs. The first one didn't take long at all. 1007 seconds. Actually, no, that was the second one. That's the one that took longer, sorry. And then the first one, 42 seconds. So, number of points here, 979,553. Number of points here, 253,792,597. So it took longer. So let's go ahead and get some more LiDAR data. So data, I'm going to make this big. So we want OpenTopography. And anywhere that's inside these red outlines is where you can select data from. Okay, so I think let's do something in here along this water. So let's go ahead and do select the region, and then let's just select this. All right, so let me see. Okay, yeah, sorry. See, I've only done this once before. That's how easy it was. So to go back, this first page, you don't have to select anything from. Come down here and click on point cloud. And then this is the area that I selected. So it brought it over. And you can see that this is going to be 21,562,000 points. So if it gets to a point where we're just waiting on this data, then I'll pause. I'll just cut the video. Okay. So, all right. So that's cool. And the maximum you can select is 250 million points. So if you go too far above that, or if you exceed that, it won't allow you to pull it in without, I guess, an upgraded account. So I don't mess with any of this, except I changed this to last because that is what the article uses. I didn't mess with any of this. I didn't mess with any of this. Did not mess with that. I didn't mess with anything. Okay. So I'm just gonna say job title for YouTube video description. Creating a YouTube video following the Medium article, whatever, and then submit. And now you'll get here, and it's going. So I'm gonna go ahead and make sure my email is up and running so I can see when it's ready. And then with that, we are going to go ahead and create the Python project and get to it. So let me move this over here. I'm just going to create a project called YouTube, and future videos that I do, I'm just going to put it in that one. So if you want to pull any projects I do, you can just go to the same repository on GitHub. I'm just going to call it YouTube. I'm going to do a pip environment, and then okay, we're going to create, and it's creating. All right, projects, cool, YouTube. So I'm gonna call this one, I'm gonna create a directory, and I'm gonna call it Lidar. And then inside of here, I'm gonna create, let's call it Lidar 1. Because in the future, what I wanna do is, actually, you know what? Let me go ahead and just, because I wanna keep this organized from the start. Let me create another directory called Python files, and then another one called last data. So I'm going to go ahead and move this Lidar 1 into Python files. Okay. And then once the last data downloads, it's not downloaded yet, or it's not complete yet. Once it's done, I'm going to put it into last data. So at this point, we're waiting on that. Let me just double check to make sure it's not complete. Okay. Excuse me. And then, nope, still working. So that's going to be a lot of points. Yeah. So the reason why I'm calling this Lidar 1 is because this is going, oh, there it goes. It's done. So this is going to use an Open 3D. It's the Open 3D package to map it. But what I'd like to do is see if I can map it in the future using Plotly. So in the future work that I'm going to do with this, I'm going to try and map it using Plotly. All right, so that's ready. So let's go ahead and download it, and I'm going to have to download it to my file. So stand by for a film jump. Nope, didn't open on that screen, so that's cool. All right, so let's go ahead and download this point cloud results. So downloading. Now you can see it's points 1 because I've already downloaded a file from here. So your first file will be called points, and then it's going to start numbering them. Okay, cool. So show in folder. All right. So what I'm going to do is I'm going to come over here. I'm going to say open and explore. And then I'm just going to drag and drop the downloaded points folder into here. But I'm going to rename it points 1 without the parentheses. Sorry, my brain stopped for a second. So we should see it populate in there. All right. So let me go ahead and refresh that. And there it is. Okay, cool. All right. So with that, we are ready to start doing this code. So I'm going to break this code into cell blocks within the Python file. It's similar to a Python notebook, but it's not running as a notebook. It's stopping the code from running once I get to a certain point. And this will allow me to hunt for bugs along the way much easier. So this is what we're going to call this. I'm just going to call this visualizing LiDAR data for YouTube video. And then I'm going to go ahead and create my first cell block with pounds %%. So you can see I'm using code cells, and I'll go ahead and turn on the scientific view. Move this here. Need all this. Okay. So the first thing we're going to do is we are going to do our imports. So I'm going to go ahead and just comment all of this stuff. So that way, whenever you go to look at it, whenever you're watching this video, it's going to be clear. So we're going to import LASP, import Open3D. And I don't know if those are dependent upon NumPy, whatever. Import NumPy is in P, import Open3D as O3D. Oh, okay. So as you can see, these aren't installed yet because we haven't installed them into the environment yet. So Python packages, NumPy, install. I was working on something else yesterday, and for some reason, it was saying, oh, actually, no, I think I was in my Linux environment doing it, but for some reason, it was saying can't install it, and then it did install it, but later I found out that my system time was off, and I was having issues with all sorts of things, and fixing my system time in Linux fixed the whole plethora of issues I was having. So anyways, so next is going to be LASP. So you can install it from here, Python package on here, or you can go to File, Settings, Project, Python Interpreter, and you can do it all through here. That's how I used to do it for the longest time, and then I noticed this said Python packages, and now I just do everything from here. And then Open3D, install. And I like how this has documentation down here as well. It's pretty cool. And if you click this, it opens the link to the docs, which I think is pretty cool as well. So that's installing. So then I have comments already set aside for these. Let's see. I'm mainly doing this now, that way I don't forget to do it later. And because we're still waiting on Open3D. So while we're waiting on Open3D to finish, let's see what's left. I'm going to go ahead and get started. So the first thing we're going to do is we're going to import. So what I'm doing is I'm looking at the code I already wrote, not at the Medium article, but you can follow the Medium article. It's basically the same thing. So that's why I keep looking over as I'm looking at the code I already wrote. So the first thing we're going to do is we're going to import this LiDAR data and assign it to a variable. And we're going to call it last. Again, I'm following along with the article. Last is equal to lastb.read. And then you have to find, since I have this broken down into different directories here, you're going to have to do a little directory navigation. Or if you just put this .last file in the same directory as the LiDAR, the Python file, then you don't have to do this. But I want to keep my stuff separate. So this is how I'm going to do this. So this is going to be LiDAR last data or LAS data, and then points one. Okay, so this is why I wanted to break this into code cells. So we're gonna make sure that each of these things is working properly. So let's see. Okay, these are all done, so I can get rid of that. And then we have, if you click here, I don't know if this is gonna update. Yeah, right here, it gives you information down here. So that's pretty cool too. All right, so we're gonna run this code cell, run this code cell, and then run this one. All right, cool. So if there was an issue with your mapping in your directories or it's not seeing the data file, then right here you would have had an issue. So if I did this, now because I had this broken off, these two don't have to run again. See? If you don't have it mapped properly, you'll get an error right away. All right, cool. So another code cell. And then, so following along with the Medium article, it examined the available features for the LiDAR file we've read. So what this does is it's simply, you're looking at the features of the file. You're looking at essentially the data that's in it and how it's broken out. So it's going to be this. Cool. So let's run it. All right. So here you can see these are all of the basically think of these as kind of like column names or dictionary keys, something like that. And then to visualize some of this data, not visualize, but just let's say exploring data, we can do last.x. Actually, let me go ahead and do this over here so it's easier. So we do last.x. So as you can see, it's an array. And then we do last.intensity. So this is just like calling a data frame and then a column, right? And then we have last.gps time. Cool. So I'm not going to have this one here because we don't have to explore it. And then we're also going to look at the classifications. I'm going to put it over here because this isn't going to be anything big. Again, I'm following along with the Medium article. So this gives you all of the different classifications, right? And to understand what the classifications are, if you go to the Medium article, as you can see, we're following along. So when he did this, he had 4 classifications. And then as you can see, I have what? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 classifications. So we can go over to the ArcGIS documentation, which I guess I'll add a link to that as well. And these are all the classifications, right? So 1 is unassigned, 2 is ground, 3 is low vegetation, 4 is medium vegetation, 5 is high, 7 is noise, 9 is water, 10 is rail, I'm guessing train, and then 18 is high noise. So we'll see how this looks. If this data set looks a little dirty, then what I'll do is I'll just import the other data set that I had that was a little cleaner. So, all right, cool. So the next thing we're gonna do is we need to we want to stack the data that we want to use together so that we can call it from the Open3D library, which is what I'm assuming is what we're doing next. Again, I'm not completely fluent in doing this stuff. This is literally the second time I've ever done this. So we're gonna say I'm gonna bring the comments that I wrote before. And then we've got point data is equal to np.stack. Let's see, last.x, last.y, last.z or z, depending on what part of the world you're from. Axis 0. Transpose on 1, 0. Cool. And then we can look at that once we run it if we want. So now we have XYZ coordinates, right? And we're essentially ready to start doing our mapping, our visualization, if you will. So here comes the visualization. And then these are just some things that I had copied from the article that I put in here. So since LastB has no visualization method, they chose to use the Open3D library. And in doing so, that you have to create the geometries and pass the point data that you created earlier, which is here, right? And then you can use the visualization to draw the geometries. So I'm just going to copy this code over. And then from here, we run this cell and we're ready to go. It's going to pop up with another window of the image or the geometry. And then pop up, where are you? I guess we're waiting for it. It is a lot of data, so it's easily over 1 million points. So let me open my just want to see if it's still, there we go. So this doesn't look very clean right off the bat. This looks dirty, nasty with noise. Yeah, that's kind of nasty, huh? So maybe in pulling the data from OpenTopography, it can filter out the noise. That looks pretty weird. So what I'm gonna do is I'm just gonna go ahead and copy the other last file into this, and then you can see how much better that one looks without noise and stuff like that. So I'm going to go to what am I doing? Oh, sorry. All right, so that's my dog, if you can hear. Copy this one. And then we're going to go and we're going to place it in last data. So I'm just going to replace the file that's in here. All right. So then so back up here, I'm just going to rerun everything. Now we're importing the new file. All the same stuff. And then finally, this one should be a little quicker. Yep. There you go. Well, that's a lot cleaner. So when you're trying to manipulate this, since there's not a lot of thing tools on here, this is why I wanted to use Plotly with it, because you can see me moving it like this. And then if you press shift and do it, you get a different rotation axis, right? And then if you use the right mouse, it's not doing anything, which on some of them it does. And then I'm using the scroll on the mouse to zoom in and out. So this was kind of like a creek bed out of like Utah, I believe it was. So that's pretty cool. It'd be cool if there were a lot more points. You can get a lot more detail in here, but it is what it is. It's nice. So with that said, that's a quick and easy way of how to visualize LiDAR data in Python. As you can tell, you don't have to know hardly anything about these packages to use them. It's very quick. It's very simple. As long as you can locate the data with using your code to locate the data where you have it saved, and then depending on how many points you have, it could take a little longer to visualize. So there was another one I downloaded. It was the max. It was like 7.5 gigs worth of points, and you lose some. It lost some finer details, like zooming in, but it was a larger range of the Earth, I guess you could say, right? So it would be probably like this big, if not bigger. You can zoom in even further, whatever. But that's how you do it without knowing that much about these packages. I'll put this stuff on the GitHub, and you can download it. You can, make changes, whatever. And if you know how to do this stuff in Plotly already, feel free to add that and do a commit or whatever, and push it, and we'll add it so people can learn. So with that, thanks for watching. Let me know what you think. If you have questions, comments, concerns, leave them in the comments. And if you want to have any requests, feel free to leave those there too. And if I forgot any links or if anything's not clear, please let me know, and I will put up another video explaining it better. All right.